A five-number summary of this distribution of 316 scores on a statistics exam is 0, 26, 31, 36, 50. And we're also told that these scores are approximately normal. The question is asking about the standard deviation of these test scores. So let's think about some things we know about this five-number summary. So we know that this is the minimum value, the first quartile, median, third quartile, and maximum. So let's say that I were to look at one of these values here in the middle, like the first quartile of being 26. Well, I know that quartile 1 is a value that is at the 25th percentile. I also know that these scores are approximately normal. So if I were to draw a picture and just sort of estimate about where the 25th percentile would be, I'm going to go ahead and label that with the score of 26 that I'm given. And the 25th percentile means that the area of this shaded region here to the left is 25%, or we can think of that as being 0.2500. So one thing we know that relates to this picture of this normal curve that could get us to our standard deviation is the formula for finding a z-score. So we learned in Chapter 2 that a z-score is the value minus the mean divided by the standard deviation. So let's see if we can find what z-score corresponds to an area to the left of 0.25. So we're going to grab our table A, and we're going to be looking to try to find an area as close as possible on the inside part of our table to 0.25. Now it looks like there's two that are very close. I'm going to choose the option on the left that's only 14 away from 2,500, whereas the other one is 17 away. So this is the area that seems to be closest. So I can see that that z-score is negative 0.67. So going back to our problem, a z-score of negative 0.67 is also at the 25th percentile. We can also plug that in over here into our z-score formula. Now the value, the score that is at that position is 26. We're trying to find our standard deviation, so I'm going to leave this as a variable. And then in order to figure out the mean that we are subtracting, so we're not specifically told the mean here, but we are told the median. That was one of the values here in our five-number summary. Now, if this distribution is normal or approximately normal, we would expect the mean to approximately equal the median. And so we can go ahead and use that value of 31 to plug in the position for the mean. Now we're just going to continue this calculation to solve for our standard deviation. So just a little bit of algebraic thinking here. We'll go ahead and do 26 minus 31 to get negative 5. Then if we multiply both sides by the standard deviation, that's going to cause the standard deviation to cancel from the denominator on the right-hand side. But then we still want to get the standard deviation by itself, so we could divide everything on both sides by the negative 0.67. It's going to look something like this. So to get my final answer here, we are going to do negative 5 divided by negative 0.67. And that's going to give us an answer of about 7.462. So it looks like that is closest to the answer choice E of 7.5. Thanks for watching.